What is what is UJT? What is UJT? Uh, Relaxation oscillator. Yes. So the UJT relaxation oscillator is an important application of the UJT. The capacitor is charged with a resistor. You know what is an oscillator? Oscillator which generates a carrier uh, in a mobile phone. There is an oscillator which generates a carrier wave. It is usually connected with a capacitor with inductor and a resistor which generates a carrier wave which transfer converting in communication system it transfer change in the frequencies so that our phone antennas are very small or else should be a very large antenna. So that the operation of oscillator is to generate a carrier wave. So here this is one of the most important applications, but here it is connected with capacitor and resistor and called as an oscillator relaxation oscillator. Mm. The capacitor voltage gradually increases. Like let's see what is difference between UJT oscillator and normal oscillator, mobile, which uses a capacitor and a inductor. As this important distinction, UJT direction oscillator and an active oscillator are both oscillators, but they generate oscillations in complete sequence. So both are oscillators, LC is an oscillator, UJT is relaxation oscillator. UJT relaxation oscillator, the UJT oscillator we just learned many uses based on capacitor plus UJT. The capacitor charges slowly and then it discharges quickly. Then the UJT fires the UJT on with time. Voltage is changing with time. So it generates a sawtooth waveform. It is called a relaxation oscillator because the capacitor gradually relaxes by charging and then suddenly releases its stored energy. But here for a LC oscillator, inductor with capacitor, here energy continues moving back and forth, capacitor electric energy, inductor magnetic energy. So you get a sinusoidal oscillation. Voltage each time the ideal LC resonant frequency is 1 by 2 pi 2 power LC. But an important correction, your phone doesn't necessarily is being good, but the circuit purpose and what happens are often changing or different. The key is a capacitor itself that reach steady state on DC. The UJT prevents it from staying there by repeatedly discharging it in a rectifier plus capacitor filter. So here this is a pulsing DC. This shows the how the pulsing DC comes to uh, DC peak into pulsing DC into steady DC. These peaks it discharges slowly through the load, so eventually get a relatively steady DC. The capacitor basically being used to remove reduce the IC So in a UJT oscillator, the capacitor is deliberately allowed to charge, but we don't let it reach a steady state. For example, here battery is connected, this is UJT and this is capacitor, this is resistor. The capacitor charges to resistor, capacitor is charging with nothing entered to the capacitor will eventually influence VCC and it reaches UJT peak voltage. So when the capacitor charges to R, so VC nothing interacted with capacitor will eventually approach VCC. But before it reaches VCC, it reaches the UJT peak voltage VP. So capacitor needs to get a steady state by getting its to peak. But here, before it reaching here, it reaches the UJT steady state peak voltage. Then UJT turns on. Then voltage low resistance discharge path occurs. Capacitor rapidly discharges. This is a fast below value point. UJT turns off. Capacitor starts charging again. This creates a discharge. So what happens here? Before it capacitor that is um, capacity capacity stores full charge or in voltage and when the here voltage increases uh, it need to get discharged when there is a it needs to get steady state. When it is stored, it should stay stop. It's enough after this will get. So what happens here? Before it getting there, the UJT is getting turned on. What the UJT does is, as voltage increases, current decreases. So as voltage is increasing, the current is decreasing. Uh, a low resistance discharge path appears. Sorry, as voltage increasing, as voltage decreasing, current is increasing. Yeah, as current is increasing, voltage is decreasing. So UJT turns on, low resistance discharge path appears. But the contribution of the current happens here. Capacitor rapidly discharges. So, because of the UJT, the capacitor is discharging. It doesn't get into the steady state. We see falls below value point. When the yes, in UJT, VC gets into a value point. So, voltage is decreasing in here. So, capacitor becomes like a discharge. Here, this is a capacitor. Capacitor is voltage is decreasing. And suddenly, because of UJT, it discharging, increasing the discharging. Why doesn't it reach steady state? Because UJT keeps interrupting the charging circuit. Without the UJT, C charges ECC and eventually IC becomes zero. And the capacitor reaches steady. With the UJT, charges CP UJT on, C discharges UJT off, C charges again. So the capacitor is intentionally prevented from reaching DC steady state and is AC following to the resistor and capacitor. The supply can be DC, you don't need an AC input. So oscillation is created by the circuit itself, DC supply. So RC changing the simulator switching period is performed. That's why it's called a relaxation. So we understood the relaxation oscillator. Now let's get into the now he said like what its applications. UJT applications for SCR trigger. UJT can generate a sharp pulse triggered to the gate of an SCR. So this UJT transistor also used in a SCR. We are going to learn it. What is it? Silicon. It's what I'm talking. Sawtooth waveform. It is in Sawtooth waveform generation in the relaxation oscillator and RC changing with UJT 5. Okay. We are now going to ready the SCR triggering. SCR triggering. SCR. First we will do the SCR. Continue SCR. Silicon, yeah. Silicon control trick is An SCR is a controlled semiconductor switch. Unlike an ordinary diode, we can control when it starts conducting with the gate. So SCR is a controlled semiconductor switch, unlike an ordinary diode which acts as a one-way valve, it allows current only in one direction. With a control when it starts conducting with the gate. So it is also like the same PN and PN, but even it is forward bias, it will not allow the current until the P gets the signal. Uh, P gets the signal to allow the forward bias. Anode, cathode, gate. So gate is connected to here it is PN. Gate is connected to third P. You see here third P. Uh, Sorry, here PN second P. Gate is connected to second P. Because these are four layers, there are three PN junctions. Three PN junctions are exist like J1, J2, J3. J1, J2, J3. So why is it called a control rectifier? Break the name apart. Silicon, semiconductor material. Uh, Rectifier allows current mainly from A to K. A to K here is said means anode to cathode. Mhm. Control the gate controls conduction rate. Controlled the gate controls the conduction level. Forward bias automatically conducts ordinary rates. But SCR can remain off. Apply gate pulse here in the third page, second page, sorry. Here in the second page, the main area the turns on. How do we correct the SCR? Think of it like this. Load is connected and SCR is connected here, PNPN. And then gate is connected, it is connected to the road. So load means let's go in a resistor. Current flows from anode to cathode. The gate is used for control. So gate is used for control. Now let's understand the three operating conditions. This is actually important. Case was reverse bias. A is negative, A is positive. Anode is in a sense what is the current potential to the anode and the positive cathode of the diode or sorry of the silicon SCR control. It so SCR blocks current. This is called reverse blocking. When we case one is reverse bias. When we put in reverse bias, like here it is connected to SCR connected to positive here and negative here. We can say like N is connected to positive and P is connected to negative. Then overall it is a reverse bias. Then SCR blocks the current. Then it's called reverse blocking. Now forward bias were not both bias. Anode is positive and the emitter is negative. Since P is connected to positive and is connected to negative, you might think it is a forward bias, so it must connect, but not necessarily. That's where here you can remain off. This is called forward blocking. So it is still remains off because it is PNPN, the second P needs to get a signal to allow the turn on the actuator. So this is a big difference from a normal diode. Case 3, forward bias plus gate pulse. Uh, the gate pulse means think in AC signal. So forward bias plus gate pulse, it is in forward bias now given a gate to the second P. Now the SCR switches on, a current is flowing, which is forward conduction mode. Three modes are there. The most important thing to understand, the gate doesn't normally carry the main load. The main current path is A to K. The gate is simply used to trigger the SCR into conduction. So gate is not a thing like adding a load. an extra current to the ongoing current. It is simply a signal that allows the that tells the SCR to allow the current towards the ground or not. Think of it as a control node. Okay. Once the SCR is turned on, something very important happens. Removing the gate post does not normally comes down. That's called latching. So after the unit tell the SCR to turn off again, it doesn't automatically turn off. Like if we do gate, we didn't stop giving the files. Then the SCR still is not turned off. That's the important use of SCR use cases. Removing the gateway does not normally turn the SCR off. That's called latching. Well, next understand why the SCR stays on after the gateway is enabled. Each becomes very easy and I continue. So where does SCR latch on? Remember the SCR structure pnpn. So we can think of your four layers are two interconnected traffic. So what I'm thinking is here PNP, this is NPN. So first we given it to PNP, then PN is forward bias, NP is in reverse bias. So it needs some, okay, let's see, read it. Two interconnected transistors, PNP, NPN, and base of the NPN. Here the base of the NPN is connected here. The two transistors feed each other. The two transistors feed each other. Then the enter SPR and collector NPN base. So we can imagine it. SPR is collector to base, NPN base. Now, this line represents the base of NPN. It is not some other input giving. This is representing the base of NPN and PNP. So PNP, the P is connected to base of NPN. Means P is connected to P. NPN. NPN has collector PNP collector connected and emitter is SPR scatter. The important thing is the output of each transistor has the other transistor. So what happens before triggering? Suppose we apply A equals to plus 1, K equals to 0. So the SPR is forward bias, but there is no gate first. The two transistor currents are initially small. PNP current is small. NPN base drive small. NPN current small. PNP feedback small. So the SPR remains off. Now give a gate pulse. We inject a small positive current into the gate of the NPN. So this is anode NPN. We give a gate pulse. The NPN starts conducting. Then it's called collector current increases. Then its collector current increases. So current from emitter to collector in PNP or NPN. For PNP we give positive voltage. For NPN we give negative voltage. And for PNP we give negative voltage. For NPN we give positive voltage. And if it is a BJT, you don't need to give separate voltages. It is like it needs to. The base and emitter region needs to get 0.7 volts to allow the emitter to flow to collector. So PNP emitter to flow collector, we need a 0.7 volts condition here. So as it reaches 0.7 volts, the current flows from emitter to collector in PNP, and collector is connected to the emitter of NPN. Yes, you are very good, but there is one important, the current directions in a PNP and reverse it from the what we said. That's not the actual 2000. From anode to awesome. From anode to cathode, PNPN, equivalent anode, it is equivalent to anode emitter to collector PNP and collector to emitter NPN. So, okay, the collector is connected in this side, emitter is connected to this side. Okay. That's the confusion. Emitter to collector, then current flows from collector to emitter. Then it is yeah, cathode. D of P and D of P and NPN. Basic NPN used to represent here, right? That's the doubt I got. PNP retransfer. For a PNP conventional current to current flows from electron to enter to collector, anode toward NPN base. So anode is connected. Anode is collector to emitter is connected to go current flows from emitter to collector. Emitter is connected to anode to NPN base. Anode to NPN base to entry. NPN transistor. For NPN transistor, current flows from collector to emitter. Not that's the correct. I was forgetting. The SR equivalent PNP NPN base current NPN collector collecting to enter cathode. The gate is connected to NPN base, so positive gate was always gate current NPN base, which makes the PNPN conduct, then the key generator action occurs. This is the important one. Gate was NPN, that helps PNPN come. This supplies more drive to NPN. That's the distinction. Here I don't understand why a anode is connected towards. Okay, anode is connected toward the NPN base, not is directly connected to NPN. So anode is connected toward the NPN base to cathode. Here collector to emitter, emitter current flows from collector to emitter, and here base of NPN base. So collector needs we shouldn't put it like a so anode is connected. Anode means the positive is connected to this side, when barrier increases, enter cathode is connected. We shouldn't look it as a forward reverse like a diode. We should look it as a transistor where current acts as a one-way wall. Here it acts as a two-way wall. We need a D signal, positive signal. So the positive signal in the P repels the P, which causes an N channel. Here we don't say N channel. It simply gets 0 some out. It's not a MOSFET, it's a BJT. It simply gets 0 some volts, and then the current flows from NPN. Here we think like it is in, look, P is connected to N, it is in forward bias. Collector of P in forward bias with N, okay? So current flows from P to N. They are also flowing from P to N. So you should understand the PNP is connected to N and N2 complete. Here P to N connected forward. Here it is P to NP, it is a reverse bias, but PN here it is forward bias. We give a voltage to P to get a 0.5 that allows the conditions of current pass through the traffic. towards capital. That's the thing. In next time, we'll learn what is uh, FCR waveform. FCR start with waveform and FCR triggering.